Hello, and welcome to lesson 1 of right angle trigonometry. We're talking SOHCAHTOA and trig ratios. First, in a right triangle, the lengths of the three sides are related by the Pythagorean theorem. I think you've all heard of the Pythagorean theorem before. If not, okay, well, first, what is the Pythagorean theorem? Let's just review that real quick. Well, Pythagorean theorem is a squared plus b squared equals c squared, where when you have a right triangle mark, okay, if you square the two sides a and b, the two legs of the triangle, and add them together, that is equal to the hypotenuse squared. That's true of every single right triangle ever. The two legs squared added equals hypotenuse squared. All right, that should hopefully be a review. You can use that throughout this unit. But this unit is all about trigonometric ratios. Okay, so trig ratios. First of all, hold on, let me get my writer here. Okay, every right triangle, we can use these three trigonometric ratios: sine, it's the first one, cosine, second one, and tangent, the third one. I would say those out loud: sine, cosine, and tangent. Okay, and that symbol you see next to them, okay, is called a theta. Theta, and I'm going to draw the theta right here. Theta. Okay. So sine, cosine, tangent, and theta. So sine is just sine of theta. If you were to punch that into the calculator and you had a degree, an angle measure, theta, because theta is just an angle. Okay, angle measure. That is equal to kind of a ratio of the triangle sides. Okay, so sine of theta is the ratio of the side opposite the angle. So if we look opposite the angle, the length of that side over the length of the hypotenuse. So sine of theta is always equal to the ratio of the opposite side length to the hypotenuse length. Cosine is always the adjacent side over the hypotenuse, the side next to the theta over the hypotenuse. That fraction is the exact same thing as typing cosine of an angle into your calculator, cosine theta, hitting enter. Tangent of theta is just a ratio of sides opposite over adjacent. So the opposite side from theta over the adjacent leg. Okay? And you can see SOHCAHTOA there in down there at the bottom. That's just a way to remember it. Sine for S is opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. So whenever I have to try to remember what sine, cosine, and tangent are, I just say SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. All right, we also have three other trig ratios: cosecant, secant, and cotangent, that are written that way: cosecant, secant, and cotangent. And all this is saying is they're just the opposite. So cosecant matches up with sine. All right. And you'll notice that it's just the opposite. So instead of opposite over hypotenuse, cosecant is hypotenuse over opposite. Secant is just the inverse of cosine, reciprocal, of cosine. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. And cotangent is just the flip of tangent, which is adjacent over opposite. Okay, those don't get used as much as sine, cosine, and tangent, but they are there. They are the reciprocals, and you will see those at some point. All right, let's practice using these a little bit. Okay, give the exact values, just reduced fractions, of the 6 trigonometric functions for theta. All right, so I'm not going to scroll up and down, okay, but I'm just going to use SOHCAHTOA. So you can scroll back and look at the equations on your previous page of notes. I'm just going to use SOHCAHTOA, so I'm going to write it up here so we can remember. All right. So sine of, and I wish there was a theta here. There should be thetas on all of these, so I'm going to go ahead and do that. Okay. So sine of theta. If we look, theta is right here. The side opposite of theta, we should always immediately label, okay, and with a hypotenuse. So the hypotenuse is always across from the right angle. So that's the hypotenuse. It's also the biggest number. The opposite side is opposite through the triangle from theta. So that's the opposite side. And the adjacent side is next to theta, the remaining one. Okay, opposite hypotenuse adjacent. So sine is opposite over hypotenuse. You can check your notes for that. So the exact value for sine of theta is 7 over 24. Okay, there it is. The exact value for cosine, well, cosine is adjacent over hypotenuse, so 24 over 25. Tangent of theta would be opposite over adjacent, so 7 over 24. There we go. The main three trig functions already filled out. Ratio is already filled out. Sine of theta, 7 over 24. Cosine, 24 over 25. And tangent is 7 over 24 for this triangle. Now, cosecant, secant, cotangent is just the reciprocals of each of those. So this one, 24 over 20 over 7, 25 over 24, and 24 over 27. You may need to just remember that. Remember that which goes with which, but there you go. All right, go and try this next triangle on your own. You are missing a side, so you might have to use Pythagorean theorem to find that hypotenuse. Okay? So do the Pythagorean theorem, find the hypotenuse, then fill out those trig functions on your own. Go ahead, hit pause right now. If you stay on any longer, you're going to see the answers. All right, real quick, I just found the hypotenuse is 74 by doing the Pythagorean theorem. 24 squared plus 70 squared equals hypotenuse squared. Squared them, added them, square rooted to get C is 74. That should be review. If it's not, look there a little bit closer. All right, hit pause, or otherwise you're going to see the answers to the trig ratios. All right, there's the trig ratios. Of course, there should be thetas in here for all those. But sine of theta is 70 over 74. Opposite, the opposite of theta is 70. So that's the opposite side. This is the adjacent side. Okay. Cosine is adjacent over hypotenuse, 24 over 74. And tangent is opposite over adjacent, 70 over 24. All right. Let's apply what we learned a little bit to the scenario. Trigonometry is one of the most useful things for real life situations. In fact, I have friends in various types of industry that use trigonometry all the time. Just knock it out by hand real quick when they're trying to calculate things. So here we go. Here's a perfect example where you might use this in industry. The water skiing competition jump has the measurements shown. Okay. To the nearest foot, what is the height above the water when the skier leaves the ramp? Okay. So we're given the hypotenuse of this right triangle is 19 feet. We want to know the side opposite of 15.1 degree angle. Okay. So I have the hypotenuse and I want to know the opposite side. Okay. Which trig function relates opposite and hypotenuse? Go back into your notes and look. It's sine. Okay. So the sine of an angle relates opposite over hypotenuse. In this case, we don't have to write theta. We have the angle, 15.1 degrees. So sine of, try to squeeze it in there, 15.1. I like to put parentheses around the angle. Sine of 15.1 equals opposite over hypotenuse. Well, the opposite, we don't know. We'll call that h. Hypotenuse is 19. Okay. Now we have an equation. Sine of 15.1 is just some number. Okay. It's just a number you can punch out into your calculator. So we have a number equals h over 19. We have to solve for h. So what's keeping h from being alone? The 19 is. Let's multiply 19 to both sides. And then I get 19 times sine of 15.1 equals h. All right, that is a number. If I punch out a calculator, I'm going to get a number. In fact, I'm going to right now. There is a sine button on your calculator, okay? It's above, in my calculator, it's above the 7, 2 buttons above the 7. So I'll put 19 times, hit that sine button, and then type in 15.1 and hit enter. And I get 4.949. I'm going to round it to 4.95. So H equals 4.95. And in this case, it's feet. If you didn't get that, okay, my guess is your calculator isn't in degree mode. It's in what's called radian mode. We'll learn radians later. What you have to do is go hit mode. It's near the top of your calculator, and you'll be able to see a place to change it to degrees. When you do that, it should work out okay. If not, ask me or your teacher. If I'm not your teacher for this, they'll be able to help you. Okay. There's one more problem. We'll do that very quick. All right, we have a biologist, and I drew it here for us, my great artistic abilities, whose eye level, a biologist's eye level, is 6 feet above the ground, and measures the angle of elevation to the top of the tree to be 38.7 degrees. If the biologist is standing 180 feet from the tree's base, what is the height of this tree to the nearest foot? Okay, so we need the height. We've got that the adjacent side is 180 degrees, and we need to know the height of the tree. Okay, notice when we get that height, we still will have to add this 6 feet down here, because remember our triangle is starting at eye line height. So once we get that age, we got to add 6 to get the overall height. Okay, so I need to find the opposite side. I have the adjacent side. I don't have any information at all about this hypotenuse here. Okay, I can only work with the opposite side and the adjacent side. Which trig function relates those? Go ahead and look at your notes. So we've got TOA, opposite over adjacent, T, tangent. Tangent relates those. So tangent of my angle, which is 38.7, equals tangent's opposite over adjacent, so equals H over 180. Again, solve for H. So I'll multiply 180 to both sides, and I'll get 180 times tangent of 38.7 equals H. Okay, I just have to multiply that in my calculator. So 180 times tan of 38.7, 144.2. Remember, and I got to add that 6 feet for the height of the eye level, which gives me 150.2 feet as the total height of the tree.